Well, last but not least, we've got section 10.5. And we're still talking about probability. This is page 430 in your textbook. But now we're talking about compound events. They can be independent events or dependent events. Events that are independent events, they are independent events if the occurrence of one does not affect the other, the likelihood that the other event will occur. So for instance, if you roll two different dice and the first one rolls on a 3, that does not affect what that second die is going to do. It could still be a 1, 2, 3, 4, 5, or 6, equally likelihood of all of those. It had no bearing whatsoever that the first die rolled a 3. Like that, if you flip a coin, let's say you flip it 9 times, and you flip heads, 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 what's the likelihood that that 10th time would be heads? Still 1 out of 2, because the first 9 flips did not affect the occurrence of that 10th flip. So those would be independent events. They do not affect each other. Down here in this picture, there's spinning a spinner and flipping a coin. These two things would not affect each other. I can flip this first and then spin that, or spin that first and flip that. Whatever this lands on has no bearing whatsoever about this coin, and vice versa. So make sure that you understand what independent events are. They do not affect each other. Okay? So then it says the probability of 2 or more events is the product of the probabilities of the events. Well, we've already been using that, where let's just say, down here we'll do this example. It says you spin the spinner and flip the coin. What's the probability of spinning a prime number and flipping tails? Well, remember the prime numbers here are the 2, the 3, and the 5. So you'd have a 3 out of 5 chance of spinning a prime number. And then the probability of flipping tails is 1 out of 2. So you would take 3 out of 5 and 1 out of 2 and multiply those. And when you multiply 3 out of 5 and 1 over 2, you get 3 over 10. Because remember, you multiply across the top to get the numerator, and you multiply across the bottom to get the denominator. So 3 out of 10. What's the probability? This is the on your own. What's the probability of spinning a multiple of 2 and flipping heads? So let's go up here. What are the multiples of 2? Well, 2, 4, 6, 8, 10, 12. But let's look on this spinner. There are only 2 of the multiples of 2 here. So the probability of spinning a multiple of 2 is 2 out of 5. And the probability of flipping heads is 1 out of 2. So you have 2 out of 5. This is for number 1. 2 out of 5 times 1 over 2. And you get 2 over 10. So that's the probability of spinning a multiple of 2. I'm going to put it times 2, multiple of 2, and flipping heads. H for heads. 2 out of 10. You could simplify that to 1 out of 5. Now, it makes sense that if we have independent events, then we're also going to have dependent events. And events are dependent events if the occurrence of one event does affect the likelihood that the other events will occur. So you have to think, does this first event affect the likelihood of the next event? So here's what I want to do. I mean, they've got, well, this is a good one. We'll use their example. It says, people are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What's the probability that one of your relatives is chosen first and then one of your friends is chosen second? So let's think about that. What's the probability that one of your relatives is chosen first? Well, you have 5 relatives there, and there are 100 people. So it's a 5 out of 100 chance for your relatives. We'll multiply that by the chance of the second thing. One of your friends is chosen second. How many friends? 6 friends. Out of how many people? Now, wait a minute. One of the people were already chosen for that first contestant. There are no longer 100 people in the audience. there are only 99 people left in the audience. That's why this is called a dependent event. The fact that this one happened changed what this one would be because one of those people are gone. So you would multiply across the top to get 30, and you multiply across the bottom to get 9 with 2 zeros. You could divide here, get 3 over 990, divide again to get 1 over 330. 1 in 330 chance that one of your relatives is chosen first, and then one of your friends is chosen second. One out of 330. Okay, what's the probability that you, your relatives, and your friends are not chosen to be either of the first two contestants? So you, your relatives, and your friends. So remember you had 5 relatives there, and you, and your friends. So that's 5 plus 1, yourself, plus 6, 12. So you're not chosen to be either of the first two contestants. Well, there are 100 people. And how many of them are not you guys? Well, there's 12 of you, which means there's 88 other people there. So there's an 88 out of 100 chance that nobody you're with, including yourself, are chosen to be the first person. What's the likelihood that nobody from your group, including yourself, is chosen to be the second person? Well, there are only 99 people left. So 99 possible choices. And how many of them are not you? Well, one of those not yous was already chosen for the first contestant. So there are only 87 of those people left. So notice this time, the fact that this happened not only affected the denominator, it also affected the numerator. And then we would do this multiplication to figure out what it is. I'm going to simplify before I multiply. I know 11 goes into both of these. 11 goes into 88 8 times, and it goes into 99 9 times. I know that 4 goes into both of these. 4 goes into 8 twice, and 4 goes into 100 25 times. And I know that 3 goes into both of these. 3 goes into 9 3 times, and 3 goes into 87 29 times. Well, that didn't make it super easy, but it did make it a whole lot easier. 2 times 29 equals 58. And 25 times 3 equals 75. So a 58 out of 75 chance that that nobody out of your group is chosen for the first 2 people. I wasn't going to do this example 3, but I am going to do it because I do like the question. It says finding the probability of a compound event. Now the way this is written, this is just a independent, these are independent outcomes, events, because they don't affect each other. And this is only out of 3 questions. So I'm going to take their question and change it a little bit. It says a student randomly guesses the answer for each of the multiple choice questions. What's the probability of answering all 3 questions correctly? Well, I'm changing this to be one of my questions on this Google Classroom, because I usually have 5 questions and they each have 4 choices. So what's the probability that you choose right on the first question? You have a 1 in 4 chance, of course. What's the probability you choose correctly on the second question? 1 out of 4 again. What about on the third question? You guessed it, 1 out of 4. What about on the fourth question? No surprise here, 1 out of 4. And of course, your chances of guessing right on the 5th question, also 1 out of 4. Well, I want to know, what's the chances that you guessed correctly on all 5, that you didn't watch the video and that you guessed correctly and got 5 out of 5? Here we go. 1 times 1 times 1 times 1 times 1 is 1, of course. 4 times 4 is 16. Times 4 is 64. Times 4 again equals 240, 256. Times 4 again. And 256 times 4 is 1,024. So you have a 1 in 1,024 chance of guessing correctly on all 5 multiple choice questions. So not likely that you'll get a 5 out of 5 on these questions unless you watch the videos and write down the answers as I get them. You have a 1 in 1,024 chance of getting a 5 out of 5 if you're just randomly guessing. Well, let's quickly do some of these exercises on page 433. It says, tell whether they're independent or dependent and explain. So you roll a 4 on a number cube, then you roll an even number on a different number cube. Those are independent. It does not matter what you roll on the first number cube. It does not affect the second number cube. They want to make that blatantly obvious. That's why they even made it a different number cube, so they could not affect each other no matter what. For number 4, you randomly draw a lane number for a 100-meter race, and then your friend randomly draws a lane number for the same race. Well, of course, they can't draw the same lane. So once you draw a lane number, that affects what your friend can draw. So the second one is a dependent event. You spin a spinner and flip a coin. Find the probability of the compound event. Well, these will be independent because you're spinning a spinner and flipping a coin. So let's look at number 5. For number 5, spinning a 3, you have a 1 in 4 chance of spinning a 3, and flipping heads, a 1 out of 2 chance, which gives you a 1 out of 8 chance for number 5. For number 6, spinning an even number and flipping tails, well, there are 2 evens out of the 4, so 2 out of 4 chance. Flipping tails, 1 out of 2 chance. That gives you a 2 out of 8 chance, which is the same as a 1 out of 4 chance. Number 7, spinning a number greater than 1 and flipping tails. Well, there are 3 numbers greater than 1. And flipping tails, 1 out of 2, which gives you a 3 out of 8 chance, just multiplying across the top and multiplying across the bottom. And finally, number 8, not spinning a 2, which means you could get a 3, a 4, or a 1, and flipping heads. 1 out of 2 gives you another 3 out of 8 chance. Down here, these are dependent events. And for these final 4 right here, it says you randomly choose one of the tiles without replacing the first tile, which means you keep the first one out, you choose the second tile. That's what makes these dependent events, because you take that first tile out and you do not put it back in. Find the probability of the compound event. So let's look at the first one, choosing a 5 and then a 6. Well, let's look at number 9. If you choose a 5, what's the probability? Well, there are 7 tiles here. So it's out of 7. And you choose a 5. Well, only one of them is a 5. So you have a 1 out of 7 chance. And then the second event, choosing a 6. Well, there's only 1 6 out of all of them. But how many tiles are left? We took that 5 out of there and we did not put it back. So there are only 6 tiles left. So this becomes a 1 out of 7 times a 1 out of 6, which of course is 1 out of 42. Number 10. Choosing an odd number and then a 20. Well, let's look how many chances of choosing an odd out of 7. 1, 2, 3. 3 of them are odd. So you have a 3 out of 7 chance of choosing an odd and then choosing a 20. Well, there's only 1 20 there, but there are only 6 tiles left because we took one of the odds out. So a 3 over 42, which is the same as 1 over 14. Number 11. Choosing a number less than 7. So, of course, it's out of 7 because there's 7 tiles. And 2 of them are less than 7. So you have a 2 out of 7 chance. Then a multiple of 4. Well, the multiples of 4 are 4, 8, 12, 16, 20, 24, 28, and so on. There are only 2 multiples of 4 here, 8 and 20. So 2 of them, but remember, we already took out one of the numbers. So only 6 tiles remain, giving us a 4 out of 42 chance, which is the same as a 2 out of 21 chance of choosing a number less than 7 and then a multiple of 4. Finally, number 12, choosing 2 even numbers. Well, the chance of choosing the first one or the first choice being even is out of 7 because there are 7 tiles and these 4 are the even numbers. So you have a 4 out of 7 chance. The chance that the next one is even would be out of 6 tiles because you already took one of the evens out. And because you already took one of the evens out, there are only 3 evens left to choose from. So the chances that you choose the first one even is 4 out of 7. And once you keep that out, the next one is only a 3 out of 6 chance of choosing an even. Multiplying across the top and bottom here gives us 12 over 42, which is the same as 2 over 7. You have a 2 out of 7 chance of choosing 2 even numbers. We'll now go over and do journal page 228 for lesson 10.5.